Hello, everyone, and welcome back to our series on knowledge tracing. Today, we're tackling a critical real-world problem. What happens when you want to use a model trained on one platform or course on a completely new one? Traditional models fail miserably. AdaptKT offers a solution through domain adaptation. It's a technique that allows a model to transfer its knowledge from an old environment to a new one, making it incredibly useful for real-world deployment. Let's dive in. Here's our plan for today. We'll start with a simple analogy to understand the core idea of AdaptKT. Then we'll break down the key concepts like source and target domains, feature alignment, and the Corel loss function. We'll do a concrete calculation demo to see how the alignment works. A crucial part of this discussion will be comparing AdaptKT to previous methods. Finally, we'll explore how this powerful technique can be integrated into your own research. To understand AdaptKT, let's use an analogy. A standard KT model is like a teacher who only knows one specific textbook. If you move them to a new school with a different curriculum, they're lost. AdaptKT is like a knowledge transfer specialist. They don't start from scratch. They first analyze the differences between the old and new environments, like question styles or student behavior, and then create a translation layer that allows the knowledge from the old environment to be applied in the new one. This is the power of domain adaptation. Let's break down the key concepts. The source domain is the environment where the model was trained, with plenty of labeled data. The target domain is the new environment, with little or no labels. Feature alignment is the process of making the data from the target domain look like the data from the source domain. The Corel loss is a specific mathematical tool to measure and minimize the difference between the two data distributions. A shared encoder acts as a translator, and the transfer weight is a parameter that balances how much we prioritize alignment versus keeping the original model accurate. Let's walk through a concrete example. We have a source platform A with a known data distribution and a target platform B with a different distribution. A student on platform B has a raw feature vector. We apply a transformation that adjusts this vector to match the mean and variance of the source platform. The resulting aligned feature now looks like it came from platform A. This allows the model, which was trained on A, to accurately interpret and predict the student's performance on B without needing any new labeled data from B. The training process for AdaptKT is elegant. You start by pre-training a model on the source domain. Then you collect unlabeled data from the target domain. The core step is jointly optimizing the model to minimize two losses: the standard prediction loss on the source data and the Corel alignment loss between the source and target features. This forces the shared encoder to learn representations that are useful for prediction and transferable across domains. Once trained, the model can be directly deployed on the target domain. This is a crucial question. AdaptKT is fundamentally different from what came before. Standard KT assumes everything stays the same. Contrastive learning improves generalization within a single environment. AdaptKT is designed for change. It explicitly models the differences between environments and actively bridges them. It doesn't need labeled data in the new environment, making it perfect for real-world deployment scenarios where collecting new labels is expensive or impossible. It's the difference between a model that works in a lab and one that works in the real world. AdaptKT is a game changer for your research. If you want to deploy your OCZIS system to a new country or school, the data distribution will be different. AdaptKT can automatically align these differences, including your multimodal data like eye tracking, without needing to collect new labels. This is also a huge win for privacy and practical deployment. Schools are often hesitant to share labeled student data, but AdaptKT only needs unlabeled interaction logs. This makes it a powerful and ethical tool for real-world educational technology. Let's summarize. AdaptKT is all about making models portable. It doesn't assume data stays the same. It actively measures and corrects for differences. It works without needing new labeled data in the target environment, which is a huge advantage for real-world deployment. By learning representations that are useful across different domains, AdaptKT solves one of the biggest practical challenges in deploying educational AI. It's the technology that takes KT from the lab to the classroom. That's all for today's deep dive into AdaptKT. We've covered its core ideas, calculations, and how it represents a significant advance for real-world deployment. Now, I'd be happy to answer any questions you might have. Thank you for your attention. Thank you for watching. If you found this video helpful, please like and subscribe for more content on educational data mining and knowledge tracing. See you next time.